This video lesson is for Chapter 6, Lesson 6, and our learning target is to use the distributive property to solve multiplication problems mentally and to rewrite algebraic expressions. Remember, algebraic just means that we're going to have a letter in there, a variable. Please go ahead and get ready with your materials and open your textbook to page 485. All right. Let's go ahead and do the Rural World link together today. They said that three friends, and that should be circled, three friends went to a baseball game. Each ticket cost $20, and all three friends bought a baseball hat for $15 each. So the book has given us an expression, 3 times 20 plus 15, and we are going to write down what do each of those pieces represent. So the 3 out here in front represents the friends. The 20 represents the cost of the ticket. And the 15 represents the cost of the hat. So let's go ahead and evaluate this expression, this part from exercise 1. 20 plus 15 is 35. And then we would take the $35, because that's how much it would cost for a hat and a ticket, and we'll multiply it by the 3 friends, and 3 times 5, do it over here, times 3. Would be 15, carry the 1, 3 times 3 is 9, plus 1 is 10. So it cost $105. Now they've given us a new version of this expression, 3 times 20 plus 3 times 15. 3 times 20 represents the ticket prices, and 3 times 15 is the hat costs. Okay, so 3 times 20 is 60, and 3 times 15 I know is 45. So 60 plus 45, again, is $105. So what do we notice about the answers here from 2 and 4? They are the same. So if I had my pick, I like this expression because I got to do this math a little easier. I knew that 3 times 15 was 45 and 3 times 20 was that way. But it's just as effective as number 2 as well. Today we're talking about the distributive property. And in words it means to multiply a sum. Remember, sum means add. And we're going to be doing multiplication by a number and multiply each addend by the number outside the parentheses. So we can see here in the example, they said if we had 2 times 7 plus 4, we could do 2 times 7, and then we can take 2 times the 4, and we can add them together. So we have multiplication twice and addition once. We could also say this in algebra terms, which simply means use variables, that we can take a times b and then a times c and add them together, and that's exactly what we did over here with the numbers. So the expressions that we used before, 3 times 20 plus 15, was equal to us writing it out longhand of 3 times the 20. Then we added to that the 3 times the 15, the cost of the hats. So 2 separate ways of writing the same thing. So the distributive property can help us when we get some nasty numbers or fractions like 4 1/3 times 9. Now I know we know the shortcut, and we would, in our regular math, we would just take 4 times 3, add the 1, and get an improper fraction and do the multiplication. But our goal here is to use the distributive property to help us do this mentally, okay? So let's break it down. And so what they did is they took, let's take the 9, and it's going to be multiplied by the 4. So we're kind of thinking of the 4 and 1/3 is the same thing as the 4, the whole number, plus a 1/3. So they're going to break it apart and say, let's take the 3 times the 4, and then they're going to say, let's take the 9 times the 1/3. So 9 times 4, that's easy for us to solve, is 36. And 9 times 1/3, we know that that is kind of easy. We can put it over 1. We'd simplify, and we get 3 times 1, or the 3. So 36 plus 3 is 39, which is a lot faster for us than if we were going to change it to an improper fraction and do all the multiplication like we did last chapter. So let's go ahead and find each product and third. So we're going to take these apart, okay? That's the same thing as 2 plus 3/5. So let's take the 5 times each part. So 5 times 2, and we're going to add to that the 5 times 3/5. So 5 times 2 is 10, and if we sneak this over 1, the 5's cancel. We get 1's instead when we divide by 5, so 3 times 1 is 3 over 1, or 3. So our final answer is 13. Let's try another one. 2 and 1/4, that's the same as 2 plus a 1/4. So we break it apart. So we're going to do 12 times 2, and we're going to add to that 12 times 1/4. So 12 times 2 is 24. And if we put the 12 over 1, we can simplify. Divide by 4, we get 3. We get 1, or 3 over 1. And 3 divided by 1 is 3, so it's 27. This last one, they kind of made it a little tricky on us. They used the decimal. But that is the same thing as 3 and 6/10. So we can make that into 3 plus 6 over 10. And that's what I want to think about. So 2 times the 3, and we're going to add to that 2 times 6/10. 2 times 3 is 6. Put the 2 over 1, and we can divide the 10 and the 2 by 2, and we get 1 over 5. So we get 6/5, which isn't all that nice. So we're going to have 6 plus 1 and 1/5, which is 7 and 1/5. Now we're going to use the distributive property with variables. Notice we have a variable in here, the x this time, but we're going to use the same procedure as before. The number outside the parentheses, this 2, is going to get multiplied against the x, and it gets to play with the 2, or the 3, excuse me. So 2 is going to play with that and with the 3. So we can rewrite 2 times x plus 3 as 2 times x, because the 2 gets to play with the x, then 2 times 3 over here. So we get 2x plus 6 when we simplify. So let's try a couple down here. So the 8 is going to play with the x, and then the 8 gets to play with the 3, and we multiply on both of them. So 8 times x is 8x, which most kids can do, no problem. We put the addition sign down, and then a lot of kids just put the 3. But the 3 has to be multiplied by the 8. So 8 times 3 is 24. Let's try the next one. 5 gets to play with the 9, so 5 times 9 is 45. Put down the addition sign, and then we do 5 times x is 5x. And it's okay if you noticed that the whole number is out in front, it's called a constant, is out in front of the variable. Usually we're used to seeing the variable first, but it's just fine going this way as well. So let's take a look at the next one. The 2 gets to multiply on the x, so we get 2x's. And we add to that 2 times 3, which is 6. So let's see how this helps us in story problems. Fran is making a pair of earrings and a bracelet for 4 friends. Each earring, or pair of earrings, uses 4.5 centimeters of wire, and each bracelet uses 13 centimeters. It says write 2 equivalent expressions and find out how much wire is needed. So they started off with the distributive property. So we get 4 friends, and we need 4 pieces of wire that are 4.5 centimeters long, and I need 4 pieces of wire that is 13 centimeters long. I could simplify this by saying that I'm taking 4 times the sum of the 4.5 plus 13, because we know that each friend needs that amount of wire. They need 13 inches for the bracelet and 4.5 centimeters for the earrings. So if we add them together, we can just multiply that by the 4 friends. Kind of like what we did with the cost of the hat and the baseball ticket and the Real World link. So now we could use this information to solve. That we can take 4.5 times 4 and get 18, and 4 times 13 and get 52. So 18 plus 52 is 70. We could also have done it by taking 4 times the 4.5 plus 13. So we add these guys together here in the middle, and we get 17.5 times 4 is 70. It's a little quicker. So we're going to need 70 centimeters. So let's try to create one of these ourselves. Each day Martin lifts weights for 10 minutes, and he runs on the treadmill for 25 minutes. And that's each day. Write 2 equivalent expressions and find the total number of minutes that Martin exercises for 7 whole days. So I could do it the long way. I could do 7 days times the 10 minutes of running on or lifting weights plus the 7 days of running on the treadmill for 25 minutes. And that would be equal to 7. And I could just add up that he works out for 35 minutes total each day. Actually, I should write this longhand first. Sorry about that. That he lifts for 10 and runs for 25 in parentheses. So we would get 70 plus and 25 times 7, 35, carry the 3, 14, 15, 16, 17, 175. And so altogether, he works out for 5, 14, 245 minutes. And we could see how this work on this side would be 7 times the 35. So 35 times 7, 35, carry the 3, 21, plus 1 more is 245. And they're both equivalent. I'd have to say I prefer this side. I think it's easier just to add them together and multiply by that 7, then I only had to do that one time. It seemed a little simpler to me. So now we're going to try to factor the expression, which means we're just simply going to be doing the reverse. They're going to give us something, an expression, that's been written as product of their factors, and we're going to factor it back out. So if we have 12 plus 8, we know the factors of 12, or the prime factorization, would be 2 times 2 times 3, because 2 times 2 is 4, 4 times 3 is 12. And we can factor out the 8, which is 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. So they said that they have these 2 sets of 2's in common. So the greatest common factor of 12 and 8 is 4, which we have done many times this year, trying to with our fraction unit. So now what they want us to do is to write each term as a product of the greatest common factor and the remaining factors. And then we're going to use the distributive factor to factor it out. So if we have 12 and 8, we think about what's the greatest common factor they have. We could take out the 4, and then we do 12 divided by 4. What remains is the 3, plus, if we divide the 8 by 4, we get left with 2, so 4 times 2. So what they want us to make is kind of like the distributive property, but we're just reversing it out and creating it ourselves. So it would be 4 times 3 plus 2. So 12 plus 8 is equal to 4 times 3 plus 2. And this is going to be helpful for us when we're doing longer algebraic expressions when you get older. So let's try a couple here together. So we have 9 and 21. So I'm thinking, what factors do they have in common? And I can think of, off the top of my head, 3. So if I take the 3 outside, now I'm going to go ahead and divide. 3 times what is 9? 3, plus the 3 times what is 21? 7. So our common factor here is, our GCF is the 3, and we could simplify this as 3 times 3 plus 7. So that's our answer. Let's try another one. Thinking about 14 and 28, I know that 2 is definitely a factor, but I also know that 7 could be a factor. But if we really get down to it, we really can pull out 14, because 14 times 2 is 28. So 14 times what is 14? 1. And 14 times 2 gives me 28. So we could put the 14 out front, and it would be 1 plus 2. Oops, sorry. Let me erase that. Got ahead of myself. 14 would be on the outside, and it would be 1 plus 2 on the inside if we use that distributive property. All right, let's take a look at J. We have 80 and 56. And 80 probably has quite a few different factors. So I'm thinking about my 56. I know I could divide by 2 because it's even, but I could also divide by 8. 8 times 7. So and I know 8 works with 10, or the 80. So let's take out the 8. 8 times 10 is 80, and 8 times 7 gives me 56. So we'll bring those 8s together. 8 will be on the outside, and on the inside it will be 10 plus 7. Let's try a couple more here. Now they want us to factor when there's a variable inside of here. And remember, 3x is the same as 3 times x. So 3x plus 15, think of it just how we did on this last one, is that what does the 3 and the 15, just kind of ignore the x, it's going to be important to keep it, but just ignore it. What does 3 and 15 have in common? Well, 3x is the same as 3 times x, and then 15 is 3 times 5. So the common factors here, the greatest common factor will be the 3. So we're just going to pull it out. So we'll do it the same as the last time. We've chosen to divide by 3. So 3 times the x plus 3 times the 5, because 3 times 5 gives me that 15. So now we can simplify by saying that 3 times x plus 5. So we're doing the same thing as we did on the last ones, except for this time we have that variable in there. So let's give it a try. Here we have 16 plus 4x. Let's just look at the numbers. 16 and 4, well, we know we can divide them both by 4. So 4 comes out front. 4 times 4 gives me 16, plus 4 times the x. So these are the common pieces out here, so I'm just going to put it out front. And then I take the stuff that's left and add it. So 4 plus x goes in parentheses. All right, let's take a look at another one. We have the 7 and the 42. Well, I know I can divide them both by 7. So I'm going to take 7 out, And 7 times what? It gives me 7x. Well, it's the x that we don't know what it is yet. Plus 7 comes out of 42. 7 times 6 is 42. So now the things that they have in common is the 7 out in front. So I pull it out. And then what remains is the x added to the 6. And there we go. Why don't you go ahead and see if you can't handle m on your own, and then pause the recording while you do your work, then turn it back on to see if your work matches mine. This one's a little trickier than I initially thought. So let's actually work this one out together. We have 36 and 30, and the greatest common factor that they'd have is the 6. Well, that's not the whole number. We usually have seen like the whole front number comes off of the variable, the coefficient. So this case, we're still going to think about it the same way. 6 goes into 36 6 times, but it's going to be 6 times x is left, and that's okay to have that. And then 6 goes into 30 5 times. So this will be a little different. We have the 6's out in front that come off, and we put our parentheses, and then what's left is we have the 6x plus the 5 inside the parentheses. Sorry about that. I should have done that one with you. But yeah, you'll be fine. All right. So it's time to have you guys give this stuff a shot. So get your practice assignment, and if you have questions, be sure to come and ask.